Alrighty, so we're just gonna go through like definition of a derivative at a point, derivatives of a function, and some derivative formulas. Okay. So what is a derivative? Just starting out, it's like the slope of a tangent line, instantaneous rate of change. Those are all ways we think about it. So some limit definitions we have are this guy right here, right? The limit as x approaches a is our f of x minus f of a divided by x minus a. And then we have in the case of 0. And then some notation is when we write a derivative, we can do like f prime. That's just what that is, little apostrophe. Yeah, apostrophe. And then we can also do df over dx. It's saying it's taking the derivative of the function f with respect to x, because x is our variable in this case. Alright, so in this first problem, it says one of 3 curves below is the derivative of one of the other two. Which one is the derivative of which one? Do you guys want to guess? Or do they not do that?
Sorry, no, I just thought that was funny. I didn't mean to.
Oh, okay. What are you thinking? What do we said derivatives were slopes and rate of change, right? So what's something we could look at to think about derivatives here?
Oh wait, no.
Is red the derivative of the blue line?
How did you come to
The way I looked at it is every time the blue is like the slope is 0, the red line is crossing 0.
So you're saying like right here, sorry, that was backwards. Right here,
Yeah.
every time that this slope is 0, it's gonna cross.
Yeah.
Does that work all the time? Oh, no, wrong one. Yeah, I agree with that. What do you guys think? Yeah? Okay, yeah. You're good. Good job, guys. Okay, so then for this guy. So this one wants us to find the derivative of the function and then evaluate it at 2. So I'm going to have f prime of x equals 2 times, do you guys want to just like shout it out? Yeah. What's this guy going to be? Yeah.
4x with the...
And this will just be the power of 1. And then what happens?
I was like,
Oh, yeah. Right. Don't be scared to yell at me if I do something wrong. It happens a lot.
I would
Okay, and then for what happens to our 2x minus 6? We'll have our
2
and then 0.
yeah, because this 2x right here is the power of 1, and you subtract 1, so it'll be 0. So we'll have x to the 0, which is just 1. Okay, so let's simplify this a little. So this will be 10x to the 4th minus 12x to the 3rd minus 10x plus 2. So now that we have our derivative, we just have to evaluate it at 2. So everywhere there's an x, we're just going to plug in a 2. While I'm doing this, think what 2 to the 4th is. Okay, what did our brains tell us? Or calculators?
16.
16? Well, it's 16 times 10.
160.
Excellent. Okay, 160 minus 2 to the 3rd.
8.
What's 8 times 12? 96. Minus 20 plus 2. Okay, I did this in advance because I didn't want to do that in my head. It's going to be 46. Do we feel okay with that? Okay.
You'll have calculators.
Oh, they have oh. You're cruising. Okay, does anybody have any questions about how I did that? Okay, cool.
No.
Okay. So for this next guy, do you want to just do 3 of you? You got it?
Yeah, let's switch off every 2.
Okay, I see.
I thought that's what we got.
Oh, you're good. I'm just kidding.
Wow.
Review Q.
Okay.
Okay, so these graph ones, that first graph one is probably your like least good bet about like a question on the exam. But this one you should be able to do pretty okay. So we're gonna identify the x values at which the derivative doesn't exist. So what's the two terms for when my derivative doesn't exist? Do you remember them? Like a corner and a cusp? Does that sound familiar? Okay, so at any point where it's comes up like the bottom of a heart, or if it's like a box, side of a box, that's going to be somewhere that the derivative doesn't exist. Okay, so where's my first point where the derivative doesn't exist? So the first point that I have a cusp or a corner.
1.
Yes, so right here. So is this a corner or a cusp? It's technically a cusp, but it doesn't really matter. Okay, where's my next one? Where's my next one where it's such a sudden change that like there's none?
2.
Mhm. And what about my next one?
4.
Yeah.
Then 5.
Yeah. Do I have any more?
No.
See, wasn't that awesome? And you're like, wow, is this even on the CBEs? Good job. Okay.
Tap on the
I am
picture.
tapping. I'm tapping quite a lot. There we go. Okay. Identify from the graph f prime of 4.5. So right here is 4.5. So these problems are going to kind of have a sort of pattern to them that the point you're looking for is going to be like along a straight edge like this. And so the point that you're looking for is going to be contained between 2 points that are defined. And so since it's just a linear slope, that means that my slope of the tangent line is just the slope of that line. Okay, so does anyone want to take a stab at what the slope at 4.5 is? You can't see it.
Oh wait.
So I'm going up
It's
up
Oh,
1, because this is -1 over here.
Yeah.
Oh, wait, whoa.
So I'm going up 1, and then I'm going over 1.
I didn't even realize that.
Okay, so I went up 1, over 1. So that would be a rise of 1 over a run of 1, which would give me a slope of 1. Does that make sense?
Yeah.
So it's just my triangle. So you're just going to basically draw a little triangle there, and that'll give you the slope. So just make sure that you know the units, though, because that obviously messed me up like 5 seconds ago. So sweet. Okay. It should say, oh, there. F prime of 4.5 equals 1. All right. Okay. So one of the first things we talked about was the product rule. So does everyone feel kind of comfortable with the product rule? Take the derivative of one times the first times the other, and then derivative of the other times the first one. It's the funnest rule. Okay, the quotient rule. Okay, I have a good like mnemonic thing for this, but I'm gonna like embarrass myself by saying it, but hopefully it's for your benefit. Okay, so call this is like low, and this is high. My like high school teacher used this, but so the way the saying goes is low, so low d high, like derivative of high, minus high, which is f d low, which is the derivative of the bottom, and then you square the bottom, which is the g of x, and away you go.
That's beautiful.
Yeah, so that's how I remembered it for like actually 10 plus years. So low d high minus high d low, square the bottom, and away you go. So there you go. And so if it doesn't rhyme, then you know that you've got it wrong, right? Because if it doesn't end in low on that second phrase, then it won't rhyme with go. So if that's helpful for you, that's good. But if not, then you can just think I'm like crazy, and that's fine too. Okay. All right.
Oh. See, you're fancy.
Yeah, I am fancy.
More evolved than me. Alright, so for this guy, what do you think we're going to use? Quotient or product? Okay, so since they're multiplied, that's kind of our tell sign that we have to use product rule. whenever we're using division of, so like we were doing f of x over g of x, that's when we're going to use quotient. Oh, this is weird to write with. Okay, so our f of x here has our two functions. So we have this little guy, I'm going to call him h of x. And what's your favorite letter? Okay, we'll do G of X.
Sticking with the classics.
Yeah. Okay, so when we find the derivative of this guy, we're going to have to use the product rule. So let's do this. H of x times g of x. The derivative of this guy is going to be equal to the derivative of h of x times g of x plus the derivative of g of x times h of x. So since it's addition, it doesn't matter which one you take the derivative of first. It just, because it's commutative, so then just pick one and make sure you get both of them. So what's our derivative of h here? Just bring down the power and then subtract 1 from the exponent. Cool. And then that'll be times our g of x, and then plus, what's the derivative of e of x? Yeah, this one's nice. E of x is like your pal. And then that'll be times x to the 5th. Okay, cool. So now we have our f prime. And then we need to evaluate it at 0. So we're just going to plug in 0 everywhere. Okay, so then this guy will all just be 0. And then this guy will always be 0. Well, that was uneventful. Okay, well.
So is e to the power of 0 always 0?
So e to the power of 0 is going to be 1, because anything to the power of 0 is going to be 1.
But
But-
then you times it by 0.
Yeah, exactly. We got these little stinkers right here that are just tanking the whole thing. So, yeah.
Okay, like if you're like negative 3e to the power of x,
Negative
how
3.
do you like how would you derive that?
Yeah, so when we do derivatives, we mainly just care about the x term, right? Because we're taking the derivative with respect to x. So in this case, our function, like the thing we're caring about that has the x in it, is just this e to the x. So we can just pretend this guy's out here, and then we can just take the derivative of e to the x, which is just e to the x. So you just, if it's multiplied, you just carry it with it.
Okay.
Because coefficients they're groovy like that. They just keep going along. I don't know if that helps you remember it, but that helps me. You guys have any other questions? Okay. Alright. Okay, what are we gonna do for this guy? Product or quotient rule?
Quotient.
Yeah, because it's division. I think I spelled quotient right. I'm like pretty sure. Okay, what's your favorite letter for this guy? Ooh, that's evil because this is F. We'll call this capital F.
Apparently you cannot have the bigger letter.
Sorry.
Yeah, shame on you. Second favorite letter?
Okay.
You guys need to have more favorite letters. Why wasn't that an instant recall? Okay, so our formula then for f prime of x is going to be, we have our f of x, so our top guy, so it's going to be f prime of x times k of x minus k prime of x times f of x all over, yeah, I heard the whisper. Okay, so do you guys want to do this all together, or do you want to find them in pieces and then combine them?
Pieces.
Okay, normally if it's like big like this, I like to do pieces. So our f prime of x, the big F, is going to be the derivative of this guy. So what are we thinking for that? Yeah,
Close.
excellent. Minus,
4x.
and what's that one do?
0.
Yeah, he gets sucked into the void. Okay, and then what's the derivative of our k? Yeah, 8x plus 3. And the 1 gets sucked into the void. Wow, those ones are not having a good day. Okay, so then we're going to have this 12x to the third minus 4x. And it's going to be times k of x, which is our 4x squared. Ooh, this is a beast. 3x minus 1. I think my biggest tip for you guys for the quotient rule is to keep track of what you've done and what you've written, because there's a lot of stuff going on right now. And then we have our k prime, which is this guy, 8x plus 3, times our f, which is that 3x to the fourth minus 2x squared plus 1. Okay, and this is all going to be over our 4x squared plus 3x minus 1 squared. Okay, and then I would make sure to read the problem and actually figure out what it's asking, because it just wants us to find 1. So I would not simplify any of this. I would just plug in 1 on the next step, because that saves you a lot of time. So f prime 1. Okay, we'll change a different color here. Is anyone red, green, colorblind? Okay, do that then. Alright, so if we were to plug in 1 right here, this would just be 12. So it would be 12 minus 4. This would be 4 plus 3 minus 1. This would be 8 plus 3. 3 minus 2 plus 1. This bottom would be 4 plus 3 minus 1. Okay, so we're going to have 12 minus 4 times, this will be 7 minus 1 is 6. And then minus 11 times 2, right? Okay, thank you. I don't have a calculator on me, but okay, this is just 36, because it would be 6 squared. Okay, so this all simplifies very nicely down to 13 over 18. Okay, do you guys have any questions about that? I know quotient rule can be kind of intense. Okay, cool, I got it right.
Yeah.
Oh, yeah, go for it.
This is just like a clarifying question. Our computer doesn't really care how we put in the answer, correct? Like if it's
Yeah.
decimal, fraction, it's all the same.
Yeah, I think if you do a decimal, I would make sure to do like a decent amount of decimal places, just to make sure your bases are covered.
Okay.
You know, I'd probably at least like 5 if you can.
Yeah.
That should be fine.
Yeah. I mean, I would definitely leave it as a fraction if that's
Yeah,
possible.
totally.
But I think that's a little bit easier for you in terms of like one extra step of having to compute. But it should be fine either way.
All right.
Okay, so are we using the quotient rule or the product rule?
Product.
Yeah. Okay, so we're gonna do a similar thing here. So I'll steal your, okay, I don't like the green though.
That's right.
I don't know how to change it. How did you change that?
Come on.
Oh!
My God. That was some static right there.
Cool. We'll name this one, I'm choosing h of x, and we'll name this one g of x. Okay, so our f prime of x. Okay, what's my first term gonna be?
6.
No, like
Oh,
in terms of h of x and g of x.
h prime of x.
Yes, you're too smart. Slow down. Okay, and then what's that times by?
G of x.
Yep. Okay, and then I'm just gonna reverse it. And you can do it either way. You just have to make sure that both of these terms are represented. So that takes a little bit of the pressure off your back, I feel like. But yeah. Okay. So what's the derivative of my h of x? Maybe I'll write it over here. It'll be neater. That gives me
6x.
yeah. Okay, and then my g prime of x is going to be, yeah, my friend e to the x. The awesomest, whatever there ever was. Okay. And then you get 3x, sorry. Why did I write it like that? It's so stupid. gives me 6x times g of x, which is e to the x. And then plus g prime of x is e to the x times my original h of x, which is just 3x squared. Okay, so once again, we're just solving this for a specific value. So you could factor out e to the x and factor out a 3x times e to the x, honestly, but it's probably not worth it to like mess up. So I'm just gonna plug in my f prime of 4. So it gives me 6 times 4 e to the 4. And I definitely recommend, if you're just putting it, like especially if it's a negative number, putting it in parentheses when you plug it in, even in the exponents. But if it's a positive number, I wouldn't worry about parentheses in the exponents. But just making sure your squareds are going in the right places and all that sort of stuff. Okay, so here I have 6 times 4, which gives me 24 e to the 4th. And then this, I have 3 times 4 squared. So order of operations, what am I going to do first? Yes. So make sure that when you're doing this, so it's 3 times 4 squared, not 3 times 4 and then squared. So just keep your parentheses, keep everything straight. So that is 16 times 3, which is 48. E to the 4th. Okay, and so then, are these like terms? Can I add them together? Yes. So that gives me 72 e to the 4th. Did that make sense to everyone?
Mm-hmm.
Like, wow, this calculus thing's pretty easy. Okay, 72 e to the 4th. Awesome. Okay. All right. So this one is looks a little bit of a doozy. But I kind of have, there's 2 different strategies I think you could take with this problem. If you see it and you think, oh, product rule, you could definitely do this using the product rule. You'll have like quotient rules in your product rule, but we can distribute, and then we'll have product rules in our quotient rules. So does anybody have a preference for what I do? No. Okay, so I will do it the way that I see fit. Did you distribute out first before you did it?
Yeah, I made common denominators.
Okay. So I can multiply these by each other, so that would just give me x squared e to the x all over, and make sure that you still have 2x plus 1 times x. Does that make sense? We're multiplying everything, which when I simplify will give me x squared e to the x all over 2x squared plus x. Okay. And actually we can simplify from there, but I won't do that as to add complexity. Okay. So now we're going to take the derivative of this, and what rule are we using? Quotient rule, yes. Okay. So I say low d high. So what's the derivative of x squared times e to the x? The product.
2x e to the x.
Yep. Plus my
2x.
x squared e to the x. Because here I have, this is, we'll call this h of x, and we'll call this g of x. So here I have my h prime of x times g of x plus my h of x times g prime of x. So if I'm doing the derivative of the top in the quotient rule, but it's 2 x functions multiplied by each other, then I have to do the product rule to get the derivative of that. Okay, sweet. Okay, minus low, low d high minus high d low. See how I did it? See? Okay. All right, and then that'll just be x squared times e to the x, and then times the derivative of the bottom, which is going to be much nicer because it's not anything crazy. It's just a power rule. So that gives me, I'll give you guys a break, 4x plus 1. Okay, everybody following till there? Sweet. Okay, now we have it all over square the bottom. So our bottom is this 2x squared plus x. So we're going to have 2x squared plus x squared. Okay, did everybody follow how we set that up? Perhaps? Okay, sweet. Now I'm going to plug in my 1, and once again I'm going to use parentheses to make sure that I am putting it in all the right spots. So I have 2 times 1 squared plus 1. And then I have 2 times 1 e to the 1 plus 1 squared e to the 1 minus 1 squared e to the 1 times 4 times 1 plus 1. Okay, I almost went off the page there. And then 2 times 1 squared plus 1. And then that quantity squared. All right. So 2 times 1 squared would just be 2, right? Plus 1, that gives me 3. 2 times e is just 2e. And then 1 squared is 1 times e to the 1. So I have 2e here plus 3e. Plus 1e will give me 3e there. And then I'm subtracting. This I will still keep in parentheses because I don't want to mess up that negative sign. Okay, so I have 1 squared times e, which is just e times 4 plus 1 is 5. So that's minus 5e. Okay, have I lost anyone? No, okay. In the bottom, I have 2 times 1 squared is 2, plus 1 is 3. 3 squared is 9. So this quantity is 9. All right, so now I have 3 times 2 plus 1, 2e plus 1e is 3 times 3e, which gives me 9e. And then minus 5e, because that was my quantity here, minus my quantity here, and then all divided by my quantity here, which is 9. And then I can combine like terms. Gives me 4e over 9. Okay, did I lose anyone? So good? Okay, yeah, just make sure that when you're plugging things in, put in parentheses and yeah, solve them out before. Like honestly, should have done like h prime up here and solve for that, and then g prime up here and solve for that, and then plug them into the equation. So, okay. And solution, I wrote all over it, but it's 4e over 9. So, sweet. All right. Back to you.
Okay, these last two are going to be looking at this graph. So it's going to be our friend for a short period of time. Okay, so it wants to know for which values of x is the derivative of the following function equal to 0. What are you guys thinking for this? What does our derivative mean in regards to like a graph?
It's like the slope.
Yeah.
The slope of the tangent.
Yeah, it's the slope of our tangent line. So when we're looking at this, where does it look like our slope would be 0?
-1, 1 to 0.
This chunk? And maybe another
2.
Yeah. At our minimum there. So this means that our x would be -1 less than x less than 0 and x equals 2. Woohoo! Do you have any questions about that? Pretty chill, pretty chill. Okay, and then this next part is you need to list in order from least to greatest for the following functions. So we need to list these kind of like in order of their slopes at these points. So let's mark these points really quick. So we have our -2, 0.5, it's like right here-ish. And then our 2 is right here, this guy. And then 3 is right here. Okay. There you go. All right, so how would you describe this one? This little chunk. Is it positive, negative? Positive. Okay, so this guy's positive. And it's like decently steep, right? It's not like insane. Yeah, okay. Semi-steep. Okay, now let's look at this guy right here. What are we thinking about this guy? Positive, negative?
Negative.
How steep is that? Yeah, if you were snowboarding, I think you'd be like that glimmer of fear. Okay, and then this guy, well, what is that? Slope. Yeah, we just said in the last one it was 0. Boring. Okay, and then what about this last guy at 3? Yeah, he's positive, and he's very steep. Whoa, 2 e's there. Okay, make one big e, and steep. All right, so which one do you think is steeper, this guy or this guy? 3. Yeah, I agree. So our negative is probably going to go last because we're going from least to greatest. So we're going to have our f prime of -2, and then our 0 right here, f prime of 2, and then this guy, which is our f prime of, wait, what did I just do there?
Here, it'd be f prime of 0.5 first.
Thank you. Oh, oh, thank goodness it saves. Okay, there you go. What? Wait, go over. Oh, that wasn't good. It's not going. I'm sorry.
No worries.
Oh, I just had to hold longer.
All right.
I just wanted to make you get up. Okay, so then this was the 0.5 you said? Okay, and then this guy was our -2. And then we have our 3. Okay, cool. Any questions about that? Okay, as you can see, I got confused with this and just our -2 in general. I kept thinking that was negative in my head, so don't do that. Be better than me. Do you guys have any questions about any of this? I believe that's our last thing.
Yeah.
No questions? Feeling so good for that test? Yeah, okay. Just a reminder, we do have the AMLAC right there in 118. So if you guys, they do online and in-person tutoring. So if you haven't taken advantage of that, you definitely should have because you're paying for tuition fees. So it's free.
Dun, dun, dun.
Cool.
There's also a bunch of resources for Calc 1 online, and there's also previous years. This same recorded review is on the YouTube channel, so.
Yeah, there's a lot of stuff on that YouTube channel.
It's true. You might hear, I recently did 995, but.
That's fair.
Yeah.
Okay, well, cool. Do we do any problems they have?
Oh yeah, well if anyone has any questions, that's great too, but we can probably end the.
You can end it, but I don't have a
Do you have a question on one of these problems?
Well, it's not on one that you guys had, but it's been on every CBE practice that I've done. Like the CBE2 practice quizzes that you can do.
Is it like, what problem was it like related to?
It's like, well, it's a product rule, but it's with like a root, but it has a 3 like in the root.
Oh, okay,
Can I solve it below here or don't we end this?
Yeah, you can solve it below there,
Okay.
that's fine.
Okay, what is your problem?
So like, for example, one of them is 7x squared times, I don't even know how to say it. The root.
Cube root?
Yeah.
Yeah.
Of x.
Okay. Is it written like this?
Yeah.
Okay, so I'm gonna rewrite this so it looks nice for our brains. Well, for my brain. I don't know if it looks nice for your brain. Okay. Do we feel okay with me doing that? Changing that square or that cube root into a power? Right? Because the square root is just to the 1/2, so it's the cube root is just the 1/3. So you're just taking the derivative of it, I'm assuming. I'm gonna see, yeah. Okay, so then we're gonna have our f of x. This is our g of x. So then we'll take the derivative of, we'll call this h. Whoa, it's so much bigger now. Okay, anyway. Oh my gosh. Okay, I'm gonna stop touching that with my hand. So then our h prime is gonna be the derivative of this f of x. It's gonna be 14x times our x to the 1/3 plus the derivative of our g of x, this guy. What's the derivative of x to the 1/3 gonna be?
1/3 x to negative 2/3.
Yeah, exactly. Which doesn't look fantastic, but I mean, hey. And then that's times our 7x squared. Okay, so let's combine this so it looks prettier. So this is a 1 power. So what's 1 plus 1/3?
4/3.
Yeah. 14x to the 4/3 plus, okay, and this is the same as 6/3. So what's negative 2/3 plus 6/3. 4/3. Perfect.
And then it asks it for like the h prime of 1.
Okay, so we'll just go in here and we'll plug in 1. Sorry, that's a plus sign. 1/4. Okay, so then what is 1 to the power of anything?
1.
So this will just be 1, this will be 1. So it'll just be 14 plus 7/3. Which, calculator. Anybody know what that is?
Well, 14/3 is 42/3, so 42, 49/3.
Cool. I'm assuming if I tapped this and there was an imaginary answer, it would be that.
Yay!
Alright, did that answer your question?
Yeah, I think so.
My biggest tip for these guys with the weird looking roots and whatnot is to rewrite them like this. Get that power into a number that you can work with. Because I always rewrite them because I cannot just look at this and be like, oh yeah, it's gonna be this.
Yeah, and you can also combine those exponents in like the first step of the problem, like we did at the end. So you can do x to the 2 plus 1/3. Okay.
When
So
you start
then-
out, that would have been faster.
So then it would be 7x to the 7/3.
7x to the, yeah.
That's not what it is. Yeah, so it'd be 7
Or wait,
times 2/3 x, and then you'd subtract 3/3 from
why would you subtract?
the exponent. It'd be 2 plus 1/3, 7/3 minus 2/3 would be 5/3.
Oh, got you. Yeah. Or wait,
It'll give you the same answer in the end, like whatever works better in your brain, but yeah. And just, I don't know, like if it has a negative exponent, you remember that like just flips where it is in the fraction. Yeah. So that's why I feel like people like the x to like the negative 1/3 is like Armageddon. Yeah.
It's a lot.
It's a little Armageddon. I'm not gonna lie.
Sometimes, okay, personally, if I can avoid quotient rule and turn it into a product rule, I will. So sometimes if you see like x to the 5th over like x, well, I guess you could just reduce that.
But you're using like, you are dividing, you know.
Yeah, that's true. But you could do this and then do the quotient rule if you prefer the quotient rule. Or sorry, product rule. That's my bad. But you can do either one.